Hello students, welcome to this session of Cube Live and we are here again. So we are going to discuss here properties of arithmetic progression. I am Subbu Nadeem and I am going to introduce you to some of the very basic properties and important properties of arithmetic progression. So what do you know about arithmetic progression, students? I hope you know what is arithmetic progression. We have studied in many classes. In class 10th we have studied, in class 11th we have studied. So arithmetic progression is a sequence or a progression where the terms are arranged in a manner that there is always a constant increase in the consecutive term. So there is a common difference involved which we generally denote by small d, and there is a first term which is a, and we say that this is the pattern which is observed in arithmetic progression. For example, if you talk about an example here, it is 3, 7, 11, 15, 19, 23, so on. So what you observe here, that there is a common difference. If you subtract the first term from the second term, you will get 4. If you subtract second term from the third term, you will get 4. You will subtract third term from fourth term, you will get 4. So there is a common difference which is called 4, and there is a first term which is 3. So if it is given to you what is the common difference and what is the first term, you can always write the series. So it will be 3, 3 plus 4, 7, 7 plus 4, 11, 11 plus 4, 15, 15 plus 4, 19, and so on. So this is what we know about arithmetic progression right now. We know many other things about arithmetic progression, like what is the nth term, what is sum till nth term, but I am not going to all those details because this is a very introductory class about the properties. So I will stick to the basic concept, that is the properties. So what are the basic properties which we see in an arithmetic progression? If we talk about the first property, it says that if there is an AP whose terms are A1, A2, A3, A4, so on, then if you add with a constant k or you subtract with a constant k where k is a positive number, then the resulting sequence is also an AP with the same common difference as the common difference of the original sequence. What do you mean by here? We mean that if we add k to this, k to this, k to this, and similarly to all other terms, what we get? We get again an AP with the same common difference as the original common difference. So if this is having the common difference d and this is an AP, then this new one is also an AP with the same common difference. Okay. If we subtract with k to every term, then again it is an AP with the same common difference. What will change will be the change in the first term and hence in the further terms. Like again we take 3, 7, 11, 15, and what am I doing? I am adding 2 to each and every term. So k is equal to 2 here, and I am adding 2. So this will be 5, 9, 13, 17, so on. Is this an AP? Yes, this is an AP. What is the common difference? The common difference is still 4, right, students? Now if you subtract 2 to each of the terms, you will get 1, 5, 9, 13, like this. You are subtracting 2. So this is also an AP with the same common difference as the original common difference, that is 4. So common difference here is also 4, common difference here is also 4, common difference here is also 4. What is the change? Is the change in the first term. Here the first term is 5, here the first term is 1, and originally the first term was 3. So if you see that there will be an AP as a resultant sequence with the same common difference. So this is the first property which we have to know. Second property is about multiplication and division with a non-zero constant. So if we take A1, A2, A3, so on, and AP, and we multiply with a non-zero constant k to each of these terms, what do we get? We still get an AP. Do we get an AP? Yes, students, we get an AP. But here the common difference will change. How common difference will change? Let us see. If we take 3, 7, 11, 15, so on. Now I am taking k is equal to 1.5. That is 3 by 2 and multiplying. So when we multiply, this will become 4.5. When we multiply 7 with 1.5, we will get 10.5. When we multiply 1.5 to 11, we will get 16.5, right? When we will get multiply 1.5 to 15, we will get 22.5. So is this an AP? Let us check whether this is an AP. So the common difference, the difference here is 10.5 minus 4.5, which is 6. The difference here is 16.5 minus 10.5, which is again 6. The difference here is 22.5 minus 16.5, which is again 6. So what we observe that there is a common difference. So yes, it is an AP, but the common difference has changed. Earlier the common difference was 4. Now the common difference is 6. So what has happened to the common difference? That the value which we have multiplied to each term, that has multiplied to the common difference also. So what will happen when we multiply 1.5 with the common difference 4, you will get 6 here. 1.5 into 4 is equal to 6. So yes, the resulting sequence is an AP with the common difference k times of the original common difference, kd. So I hope it is clear to you, students. Now we can proceed with division also in the same property, and similarly we can say if we divide each term by a k, which is a non-zero constant, and we get a sequence which is also an AP in the similar manner. What can you tell about the common difference of this AP? Can you tell me, students, what will be the common difference of this AP compared to the original AP? Will it be D? Will it be K into D? What will it be? Or it will be D by K? Yeah, it will be D by K. So we will divide D with K. Earlier we are multiplying D with K. So obviously, since all the terms are getting divided by K, so the difference will also get divided by K. So this is the next property. Now we will see few questions based on these two properties. So it is important always to apply in maths, then only the concept would be clear. So what am I doing here? I am taking a question in which it is said that 1 by A, 1 by B, 1 by C are in AP, and it is further asked to tell that B plus C by A, C plus A by B, and A plus B by C. With what sequence is this? Is this an AP? Is this a GP? Is this a HP? Or is this none of these? So you have to sort of find out. So what we will do here? We will proceed by properties. Of course, we can proceed by definition also, but our focus is the properties here. So we will proceed by properties. So if we see here, this is an AP. So what we will say, let us multiply a constant with all the terms. So I will multiply with A plus B plus C. So A plus B plus C is multiplied to this, A plus B plus C is multiplied to this, and A plus B plus C is multiplied to this. So this is a constant with which we can multiply all the three terms, and this will also be in AP by our second property. Now what we will do, we will take LCM separately. So we can say that this is A by A1 plus B plus C by A, and here A plus C by B plus B by B1, and here A plus B by C and C by C is 1. So this is how we can write it. So what we are getting, 1 plus B plus C by A, 1 plus B plus C by A, this is the first one. Next one is A plus C by B plus 1, A plus C by B plus 1. Next one is 1 plus A plus B by C. Now what would we do next? We will subtract by 1 to all of the terms, because this is an AP. So if we subtract by a constant 1, that would also be an AP. So we will subtract by 1. So minus 1, minus 1, minus 1. What would happen? 1 and minus 1 will cancel, 1 and minus 1 will cancel, 1 and minus 1 will cancel, and we will get B plus C by A, comma C plus A by B, comma A plus B by C as an AP. Is this what we have to show? Let us see. B plus C by A, C plus A by B, B plus C, A plus B by C. So this is what we are getting here. This is the same sequence and this sequence is an AP. So we can of course say that if 1 by A, 1 by B, 1 by C are in AP, then this sequence is also in AP. There is an extension of the same question which says show that A into B plus C, B into C plus A and C into A plus B is also an AP. Again the given condition is also same. If 1 by A, 1 by B, 1 by C are in AP. So how can we proceed? Just think about it. How can we proceed here? Where can we multiply, divide, add or subtract with some constant and we finally get this result? Yes, we can do something like that. So let us see, let us think about it. So what I am thinking here is, let us first multiply with ABC. Earlier in this previous question what we did, we added, we multiplied with A plus B plus C. In the first step it was A plus B plus C, with which we multiplied to all the terms. Now here we are not multiplying with A plus B plus C, here we are multiplying with A into B into C. So if we multiply with A into B into C to all the terms, what will happen? This will be ABC, this will be ABC, this will be ABC. Now A will cancel and you get BC, you get here CA and you get here AB and this is in AP. So BC, CA, AB are in AP. Now how do we get this sequence from here? So just think about it. So we have BC, CA, AB which are in AP. Now what am I doing is, I am subtracting something. What that something is? AB plus BC plus CA. Here I am subtracting AB plus BC plus CA. Same constant I am subtracting. I am not changing the constant. I am subtracting with the same constant to all the terms. So this is how this we are getting is an AP. Now if we see here, BC and BC will cancel, CA and minus CA this will cancel and AB and minus AB will cancel. So what we get is minus, this will give you common A, B plus C and there we get a common B, the minus sign A plus C and here we get a minus sign and C common B plus A. So this is an AP. Have we got the result? Let us see once again. So here there was no minus sign, AB plus C, BC plus A, CA plus B. So we have almost got the result. What we have to do here is just multiply by a constant which is called minus 1. So K is equal to minus 1, multiply with this K to all of them and you will get AB plus C and BC plus A and CA plus B as an AP. So using properties, these questions can also be done very easily. Also you can do these questions by the definition of the AP. So we come to the next property. So we have done two things in the first property, two things in the second property. With this is the third property. The third property says if we generally take three terms in an AP, we take them like this: A minus D, A plus D. Most of the cases like this, because in addition cases the D will get cancelled. So we will see an example. So this is three terms in an AP. So three terms in an AP is generally taken like this, where the first term is not A, but the first term is A minus D. This is the first term. And of course, this is the second term, this is the third term, and D is the common difference. So can we apply this in any question? So let us see a question here where we can see that how it simplifies the situation. Although we can take as A plus D, A plus 2D, that is also fine, we can solve, but that would be quite lengthy. So in order to avoid lengthy calculations and complex calculations, what we do, we don't take A plus D, A plus 2D. Instead we take A minus D, A plus D. So let us see a question here. It is given that in an AP, the sum of three terms of the AP is equal to 21. And it is further said that the second term is 6 less than product of first and third term. So this is the situation which is given to us, and now we have to find the three terms. So three terms sum is 21 and second term is 6 less than product of first and third term. So we can suppose that the three terms here are a minus d, a and a plus d. Okay, these are the three terms in AP. So sum of the three terms. So a minus d plus a plus d is equal to 21. What happened that minus d and plus d cancels and you get 3a is equal to 21. So you outrightly get a is equal to 7. So it won't be a big problem in calculation. Next part is the second term is 6 less than product of first and third term. So what is the product of first and third term? So a plus d into a minus d, of course. So a plus d into a minus d. By our formula it is a square minus d square minus a, which is the second term, is equal to 6. This is what we mean by this statement. We are multiplying third term with the first term and subtracting the second term, and we are getting 6. D is a is equal to 7. So this will become 49 minus d square minus 7 is equal to 6. So what will be d square? D square would be, this would be 13 here, and then 49 minus 13 will be 36. So we will get d is equal to plus minus 6. So we can take either 6 or minus 6. In one case it will be an increasing AP, in another case it will be a decreasing AP, terms will be same. So let us take d is equal to 6. So what are the terms? So terms are basically, here there are chances of error. So don't take a plus d, a plus 2d. The terms are like this. So a minus d. So 7 minus 6. So 7 minus 6 is 1. Then a, that is 7. And then a plus d, that is 7 plus 6, that is 13. So these are the terms. If you would have taken minus 6, first you would have got 13, then 7, then 1. So that is only the reverse order, the terms would be same. So you can take either plus 6 or minus 6, that is not an issue. So 1, 7, 13 are the terms. You can cross check whether you have done the question correctly or not. So the sum of the terms 13 plus 7 plus 1 is of course 21. So it is fine here. What about the product of the first and the third term? 13 into 1 is 13. 13 minus 7 is 6. That is also correct here. So it is a correct calculation here. Now we talk about another property, which is the fourth property. Fourth property says if we are taking terms which are 4 terms, like not 3 terms, 4 terms, then what is the best way to take those terms? Should we take a plus d, a plus 2d, a plus 3d? So that is also fine, but it would be again a lengthy complex calculation. So what we will do, we will take those terms in such a manner that it would not be a lengthy calculation. So here what we will do, a minus 3d, a minus d, a plus d, a plus 3d. So this is for 4 terms. So for 4 terms what we take the pattern is, again because we want the sum in such a way that d get cancelled off. So that is why we are taking it like this. So this is the first term of the AP. And if we talk about the common difference, so don't think that d is the common difference here. The common difference is actually 2d. Because if you subtract these two, you will get 2d. Or you subtract these two, you will get 2d. Or you subtract these two, you will get 2d. So common difference is 2d. Keep this in mind. Now let us see a question where we can apply. So there is a question here which says that sum of 4 terms of an AP is 50. Right? This is the first condition. Further it is said that the greatest term is 4 times the least term. So the greatest term of that AP is 4 times the least term. And we are talking about an AP, of course, here. This is all about AP. So let us take the terms. So we will take terms like this, that a minus 3d, a minus d, a plus d and a plus 3d. Now if you add them, all the 4 terms, what we get? A minus 3d and then a minus d, then a plus d, then a plus 3d. What would be that? That would be 50. Now we will cancel minus 3d with plus 3d and minus d with plus d. Sorry, this is plus d. This is a. So we will cancel d with minus d and 3d with minus 3d. Like this. So what we get? 4a is equal to 50. So A is equal to 50 by 4, which is 25 upon 2. So here this is not the first term, this is A. First term is A minus 3D. So what is the next condition? Is there any next condition also given? Yes. So because we have two variables A and D involved, so we have to have two conditions. Then only we can solve the equations and get the two variables. So one condition we have done with. Now it says that the greatest term, which is A plus 3D, is equal to 4 times of the least term, which is A minus 3D. So let us do this. Now we have already got A as 25 upon 2. So A is 25 upon 2 plus 3D, and here A is 25 upon 2. So 4 into 25 upon 2 is 50 minus 12D. So this would be like this. Now we get 3D plus 12D, 15D is equal to 50 minus 25 by 2. So that will be 75 by 2. So this is 15D. Can you get D from here? So as we know, 15 into 5 is equal to 75. So D is equal to 5 by 2. So we have got D also. This is not the common difference. Common difference is 2D. This is D. So what are the terms? Can you tell me the terms now? Yes, of course, it is easy now to tell the terms because you have to just substitute the values of A and D. So A is 25 by 2 and D is 5 by 2. So what do you get here is 25 minus 15 by 2, which is 10 by 2, 5. So this would be 5, the first term. Next term is A minus D, 25 by 2 minus 5 by 2. That will be 20 by 2, that is 10. Next one is A plus D. So it would be 30 by 2. That will be 15. And now you know the pattern. Still let us calculate. So 25 plus 15 will be 40 by 2. That will be 20. So this is an AP here. So this is how we solve the questions of 3 terms as well as 4 terms. Now let us see the further property which we have. So further property we have is fifth property. It says that if we have 3 terms in AP, we can always take those 3 terms in AP in such a form. If it is XYZ in AP, then you can say that the middle term Y is equal to mean of the first and the last term. How can you say like that? So you can say that Y minus X is the common difference here and Z minus Y is the common difference here. So Y plus Y would be 2Y is equal to Z plus X. So you can of course say Y is equal to Z plus X by 2. This is also given a particular name when you will study arithmetic progression. It is called arithmetic mean, or which we in layman language call the average, but it is arithmetic mean. So this term here Y is called arithmetic mean or AM of X and Z. So if this is an AP, then Y is the arithmetic mean of X and Z, and it is written like this. Next property which we have is the sixth property, and the sixth property says that if we have the nth term of an AP, then that nth term of an AP is a linear function of n. If it is nth term of an AP. What do you mean by a linear function of n? So if we talk about a linear function of n, it simply means that nth term is an plus b form. This is linear. It is, if it would have been quadratic, then it is an square plus bn plus c. If it is cubic, an cube plus bn square plus cn plus d. So this is a linear. So if you remember the formula of nth term, and in the first slide which we have discussed a while ago, if you see the starting of the lecture, there we have written the nth term. This is the nth term. What it is? A plus n minus 1d. And we also know this. This is the first basic concept, that a plus n minus 1d is the nth term of an AP. So if you say that nth term of an AP is a plus n minus 1d, and we can write it as a minus d plus nd after opening the bracket. So this is A minus D plus ND. So as you can see clearly that isn't it the linear form? Yes, it is the linear form. As you see here that A into N, so N into D. So the common difference is equal to A. That is the coefficient of N. That is the coefficient of N is the common difference in the linear expression. And what is B? So B is A minus D. That is the difference of the first term and the common difference. So B is A minus D. So you can always say that nth term of an AP is a linear expression of the term with respect to n. So we can say that this is an is an plus b. So I think that were the properties which we have to be discussed today, and these are the very interesting properties. When you will apply in questions, you will find many ways in which you can shorten the calculation and it will help you. There are many lot of things to discuss, and I hope that you would enjoy our classes, our app, and you will of course join our lectures in the future classes. Thank you, students.